No, this. That, my friend, is what we call a blinder, or a blinder in my country for some reason. And it's basically just meant to be a light that blind people. I love those effects when they are with an actual tungsten lamp, but this is the newest generation with the very Chinese cob LED, and this is super Chinese. There is not even a brand on it. It's no name as it can get. And it's not even just a warm white, it's a cold white and RGB. If you, for example, want to blind in the crowd with red, I don't know. Don't really understand those new fixture, but yeah. It's kinda like new computer with RGB. It looks super cool, but for a stage, I mean, it doesn't have to be RGB, so why? So this is brand new. Almost brand new, like 1 or 2 weeks, but one of the LED doesn't lit up. So the customer tried to figure out what's going on, so he removed the cover here and tried to reverse the LED in here. And when he changed the LED, the socket LED, the other one was working and the other one was not, so it's most likely a problem on the board and not the LED. That's pretty cool because that eliminates all of the problem that I have to deal with this inside this box here. I don't have also to deal with this power supply here and none of this stuff in here. By the way, what? Bro, you got to be kidding me, man. Alright, so if you don't spot the issue here, so this is the input power. So mains comes in here and it goes to the power supply. And then from the power supply it's bridged to this cable here, that's for the outputs. And on the output there is a fuse. But normally when you put a fuse for the device, it's for the inputs, right? The inputs is bridged to the outputs and also to a fuse and then to the power supply. So I managed to put the fuse in the wrong place. Come on, guys. Alright, let's fix that. It's not too hard, I just have to invert those two wires here. There. Oh, it's kinda stuck. Oh. You know what? It's even worse. The ground. Well, there is no ground. So that's illegal. Oh well, I guess not my gear. So what do we have here? The power supply is here. It's probably 20 volts. No, it's 12 volts. I thought it was 24. 12 volt supply here. Shush. There is a bunch of MOSFET or transistors, I don't know for now, and each one of them is for driving a separate channel. So 1, 2, 3, 4 for one side, 1, 2, 3, 4 for the other LED. The LED plugs in here. So why 4? Because it's RGBW LED, so red, green, blue, and white. Here. What? RGBW Y P V A. What? Doesn't make any sense, bro. Well, I'm pretty sure that's because I utilize also this board for power can LEDs with RGBW. Y will probably be yellow. P, I have no idea. V is for UV and A is for amber, so mostly kind of a orange color, I guess. Those MOSFET are driven by this driver most likely, and they are switched by this main CPU here. The little mic, little power supply here. Yeah, it's very simple. Yeah, and this is the I/O pin for the input-output board here with the LEDs and button. and this is for just the DMX. Pretty straightforward. Basically for this one I'm willing for a MOSFET issue or probably a driver issue. Hopefully not the CPU because I wouldn't be able to fix it. For that I will hook up my oscilloscope and probe on the input and the output of each transistor to see if they are doing their job. I put my ground here at the power supply. And by the way, it's 36 volt power supply and a little 12 volts. That's utilized for the fan on the back of the LED. There is a heatsink. So I don't need the control pad here with the button and screen to make it operate. It can do it on his own. It will cycle all of his color. I hope you can see that. By the way, it's quite funny because every time the LED is powered, the fan goes a bit higher RPM. I know that's not a feature to improve the thermal performance, it's just because this power supply is regulated only on the 36 volts. And when you consume a lot of power with the LED, there is a feedback circuit that feed the transformer with a little bit higher duty cycle to compensate for the high current. But since it's the same supply as the 12 volt, well, the 12 volt is getting a bit higher because 12 volt doesn't consume more. Yeah, I think it would be better to utilize LM7812 regulator standard all-in-one regulator for the 12 volts. So let's go on the gates here. And as you can see on the oscilloscope, we have a duty cycle. Let me decrease a little bit more so that you can see the PWM signal. Yeah, so that's okay. Now on second channel, yes. Third channel, yes. And then here it's okay. So that's for the working channel, I guess. Now let's go on the gate of the other channel. I cannot see nothing. Yeah, so I think MOSFET are fine, but the control circuits that control the MOSFETs are gone. I can see nothing. So as you can see, for the MOSFET driving circuitry, there's quite a lot going on, but let's simplify it in two stages. So the information, the data goes out of probably this resistor here and this resistor here for the last channel, because I didn't have enough room on this area here. So then it goes to this tiny little transistor here, and then it's fed into this circuitry. So at least let's check here on the resistor if the CPU is sending some signal. If I don't see anything in here, this board is just gone. I couldn't fix that. Finger crossed for the customer. Alright. It's not good. I'm just getting a high level. That's not good. Just in comparison, this is what is getting fed to the other channel that is working nicely. So as you can see, it's in reverse polarity. So high means off and low means on. So this LED is off, and now it's around 50% and then back to off. But on those one, nothing. Huh. Yep. Can't get my head why those CPU blow like that. Is it because of a lack of decoupling capacitor? Maybe, because this is an ST microelectronic chip, so I mean it's quality. Maybe it's lower grade or rubbish parts, you know, that they risk you to utilize in those. Well. Look, I'm probing just on the output of one of the broken pin on the CPU, and look how the signal looks. It's all dirty, and you can even hear this sound. I will quiet a bit and try to close up the mic. Hopefully you can hear that. Yeah, so just putting a so little decoupling capacitor and you end up with a super dirty signal, noisy circuitry, and very not reliable CPU. Yeah, this is very not a good product. I really don't recommend you buy this kind of crap. It's not meant to last more than a couple of minutes. I talked to the customer to decide whether it's worth fixing this. We decided that we weren't going to fix it as new, but just push together this thing so that the second LED can at least be lit up with the same channel as the first one. Because every time you use this fixture, it uses both LEDs at the same time. So I'm going to have a look at the motherboard to see where I can butch this little bridge. And of course, one is copper, that's, or at least copper plated, that's nice, and the other one is just plain aluminium. And by the way, already oxidizing. Crazy, wow, this thing is a mess. Alright, so here is our board. Now I could basically plug both LEDs to this driver here, but that's not a very good idea because that will consume twice the current on this MOSFET, and there are good probabilities that they are going to blow. So yeah, I'm going to attach some wire from the input of the first stage driving circuitry in here, so that the driving circuitry are separate, and that limits the current on each component. I got a new tips for my cylinder oil, a much thinner one, which is going to be nice for SMD component here. Of course, a willow one. It costs around 10 times the price of a cheap Chinese one, but it's at least 10 times better. So let's remove those resistors here, because we won't need them anymore. They are so tiny that I don't need to heat up both pads at the same time. That's cool. I need to go from this resistor to this. I'm going to solder the wire on the pad just in here so that it looks a bit better. That wire going across. So yeah, little wire and bridge. And it's burning myself with a little wire time. Let's go!
Hey kid, don't ever let them get inside your head. They'll tell you what to do in life instead of everything you know that you could get. Don't let them guide your life towards regret. I'll fight for what I love with.
Before rewiring every cable, I want to make sure that they are in the right order, because I wire them so that it's like white white, red red, green green, blue blue, but maybe it's white white, red red, blue blue and green green. And in this case I will have to redo the cabling, but that's not a big deal. Let's try it just with those two channels. Moment of truth. Of course I need the actual program because... Let's go with the DMX controller, that's easier. So it's green of course because some of the wires are not plugged and they are pulled up from the circuitry. But if I go to here, I put a blue. Here is definitely getting some blue. And now if I go with white, here I definitely got some white. Nice, it's the right wiring. I can continue.
Just be patient, make a statement, try to enjoy your life. They'll try to kick you while you're down. They wanna rise up while you drown. They wanna fill your head with doubt. They're silently scared.
Now for the last one, this resistor, I don't think that I'm going all the way here. I'm economizing my cable. So yeah, from here I'm going to trace some kind of a path to here. Here it is. It's pretty good. Not perfect. I prefer a straight angle, but that will do it. Now testing time. Alright, here we go. So first one, red, cool, green, blue and white. Super nice. Well, I can remote everything and yeah, this is fixed. Only three screws. Wow, this is so complicated to say, man. Oh well, only 3 screws. The first one is not even here in the hole, so it's OEM, if I should say. Wow, yeah. Here it is. Super cool. This is it. It's repaired. It looks good. It's better than it was, but yeah. I just want to wrap up all the reason why you shouldn't absolutely buy this kind of product from AliExpress and China. That because, well, as you can see, there were no ground protection. The fuse was in the wrong place, and by the way, I replug it in the right way, so it goes from the power, then to the fuse, and then to the power supply. But then from the power supply it goes to the output. That means that the output is on the same fuse as all the units. The thing is that this is a 5 amp fuse. So if you put this fixture at maximum brightness and you consume around 4.5-5 amp The moment you plug something on the output, it blows the fuse. Nice fixture. By the way, look at the quality of the fuse itself. There is a hole inside. That's incredible. Wow. This is dangerous, and this can kill all your show if you plug something on the output. The menu are just an absolute mess, and wow, the worst menu I have ever touched. The motherboard has one little capacitor, that's not enough for the whole unit, and of course the CPU is dying because of this lack of capacitors. Yeah, it's not very powerful. I mean, I'm not really blinded by the light. Got it? It's very loud. It's pretty heavy for what it is. Yeah. No. Don't take the risk. That's it for this one. I hope you like it, and I see you for the next one. Have a nice day.